Hello friends, Mr. Burrell here. We're in the middle of our review unit for Math 2 here. We just finished talking about a couple things, some kind of intro stuff as far as getting us ready for what we're going to be talking about the rest of this trimester. That's kind of what we've been starting with, some basic review. So this lesson is no different. This is stuff that you've probably already learned. It might be a little bit distant in your brain. It may have been a minute. We're going to talk about solving multi-step equations. We just talked about like the difference between simplifying, solving, and evaluating mathematical expressions. So today we're going to talk about solving multi-step equations. We're going to focus on the solving part. So by the end of this video, these are the things that I hope you're able to do. I want you to be able to solve equations for a given variable using multiple steps. So we're going to solve equations for a given variable using multiple steps. Okay, so remind me, what are we looking for when I'm trying to solve an equation? When I'm trying to solve an equation, what am I looking for? Well, we talked about yesterday that when I'm asked to solve, I'm usually going to have an equal sign with like some stuff on one side and some stuff on the other side. This is an equation. When I have some like numbers and letters or variables on one side of an equal sign and then numbers and variables on the other side of the equal sign, that is an equation. When I have this equal sign, that's an equation that I am able to solve. When I say solve, typically I'm asking you to find a certain variable, get a certain variable by itself. In this case, it would be x. So, consider this. I have two different equations. If I gave you the instruction to solve for x in these equations, what would you do? So take a look at these. What would you do? So hopefully these steps are kind of familiar in your brain. But right here, for example, if I have 2x equals 30, in order to get x by itself, I need to undo everything that's being done to x. So for example, this is 2 times x. How do I undo timesing something? Well, I undo that by dividing. So I can divide by 2 on the left-hand side of this equation. And whatever I do on the left-hand side of the equation, I have to do on the right-hand side of the equation. So these 2's would cancel out, and I'd be left with x is equal to 30 divided by 2, which is 15. So that's a pretty straightforward, basic example. If those steps were a little bit unfamiliar to you, that's okay. I'm going to review them on the next slide. But these equations right here are ones that would need to be solved because they have an equal sign in there with stuff on both sides. So again, when I say solve for x, getting x by itself, I have a little humor here for you. I saw an example of this on a test once. The instructions were to find x, and someone was like, here it is, there it is. Anyways, that's not what we're doing. We're not just circling the x here. When we're solving for x, usually when we're solving for x, in the real world, when I have an equation that like represents something, actually models something in the real world, x usually represents a variable that is some unknown quantity in a relationship that we are trying to find. So when I have a mathematical equation, in the real world, usually it represents something where x is the thing I'm trying to find. X is some value I don't know that I'm trying to find. So, for example, why would we need to know this? Why in the world would we need to know how to solve equations like this? Where do equations like this even come in handy? And we'll probably solve this one later. We're not going to solve it right now. But for example, this is a problem that I found. It says the state fair offers a discount for group admission. A group of 25 kids purchased 25 passes and 25 concert tickets. So they bought 25 passes to the fair and 25 concert tickets. Each concert ticket costs $15. And like say I'm going to pay for everybody's tickets and passes, and the total cost of admission is $512.50. What I have to decide is how much did each pass cost? If I paid for everybody's tickets and I need to determine how much each person needs to repay me for the passes to get into the state fair, I need to find what the cost of each of those passes is so they can Venmo me or send it to me or whatever. this is an example of a situation that I could set up and model with a mathematical equation. And I could use that equation to solve for the cost of each of these passes. Again, this is an example that we're going to return to later, but I wanted to put this up here just as an example for you. Okay, so algebraic equations, I say algebraic, that just means the math where we're dealing with like variables and solving equations and things like that. Algebraic equations like this can be helpful to model real-life situations and more easily find unknown numbers or values. So some examples, these are just a few, there's so many, just some examples of where solving equations and like math equations can be used in the real world. Architects use math equations to find unknown like measurements and things when they're building houses or like buildings and companies and things like that. Actuaries use mathematical equations a lot. Scientists, I put nuclear scientists just because I feel like that was a fun word. Every single scientific field you go into, you'll have to use some sort of algebra equations. Comparing salaries, say you're applying for jobs and you're trying to compare the benefits or the differences between two different companies' salaries and benefits. You can use equations to model that. Estimating how much money you have in like your bank account over a certain amount of time. Say you're applying a certain amount of money each month and you want to know how much money you're going to have after a certain amount of years. Though that kind of situation can be modeled with a math equation as well. So we use math, these types of equations all over the place. And we'll see some examples of that here soon. So, again, solving equations isn't something foreign. It's something you've probably been exposed to, hopefully have been exposed to before. So when I'm solving equations, these are kind of the basic steps that I follow. You may have heard it explained a little bit differently. But typically, when I have an equation, say like this, my step is I'm going to simplify both sides where possible. So if I need to simplify either of the sides of the equation, I do that, which is what we've already done. Simplify we talked about yesterday and the day before. We kind of talked about simplifying things. So on both sides of this equation, I wanted to ask myself, can anything be simplified? Can anything be broken down smaller than it already is? Can anything be combined? Things like that. For example, do I have some x's on one side that I could combine together? Or some numbers on one side that I could combine together? Any like terms, things like that. In this case, I can't. There's nothing that I can combine on both sides. So I skip that step. Step 2 is get all the x's on the same side. If I have an equation where I have some variables on one side and some variables on the other side, I want to get them all on the same side. In this case, here's an x. And that's the only one. So all my x's are already on the same side. So I can skip that step. Step 3, I solve for x by reversing the order of operations. So in general, this is how I solve equations. When I was simplifying using order of operations before, I looked for grouping symbols first. And then I moved left to right, multiplying and dividing. I did my multiplication and division. And then I did my addition and subtraction. That's what I did before with order of operations. When I'm solving equations, I'm going to go basically backwards. So first I'm going to take care of addition and subtraction, and then multiplication and division, and then look for my grouping symbols. So keep in mind with an equation is kind of like a teeter-totter or like a balance. I have some stuff on one side, and it has to stay equal to the stuff on the other side so it stays balanced. So, for example, in this equation right here, I have 4x plus 12 equals 16. So I need to get x by itself. So I'm looking at my steps here. First of all, I'm going to want to take care of my addition and subtraction. So right here, I have 4x plus 12. Well, how can I get rid of a plus 12? Well, the opposite of adding, or plus, is subtracting, or minus. So I'm going to subtract 12 on the left-hand side. But remember, this equation is like a little teeter-totter. Whatever I do to one side of the teeter-totter, I have to do to the other side, or else it'll not be balanced anymore. So if I subtract 12 on this side, I have to subtract 12 on this side. Okay, 12 minus 12 is 0. and I'm left with 4x equals 16 minus 12 is 4. Okay, I've taken care of my addition and subtraction type stuff. Now I have 4 times x. This 4x means 4 times x. I need to undo that. Like unzipping a zipper. How do I undo 4 times x? Well, the opposite of multiplying is dividing. So I'm going to divide by 4 over on this side. Remember, whatever I do to one side of the teeter-totter, whatever I do to one side of the equation, I have to do on the other side, because an equation has to stay balanced. So if I divide by 4 on this side, I have to divide by 4 on the right side as well. Well, 4 divided by 4, that cancels out to be 1. So I'm left with x equals, and then 4 divided by 4 is 1. So my answer is x equals 1. Then to double check myself, just to make sure that I actually know what I'm doing, I'm going to go ahead and plug 1 back in here for x. So if I want to double check, I'd go ahead and instead of x, put 1. So 4 times 1 plus 12. 4 times 1 is 4, plus 12 is indeed 16. So I know I did it right. It's a good habit to get into to check your work once you've finished. So that was like a pretty basic equation that I kind of dumbed down into a lot of broke down the steps really plainly and simply, but I think it's valuable to see that. Okay, let's do a few more, just really quickly. So if I have 4x equals 12, I look at the things being done to x. Well, all that's happening over here is I'm multiplying by 4. To undo multiplication, I divide on both sides, which gives me x equals 12 divided by 4, which is 3. Second one, I have x times 1/3, or 1/3 of x equals 5. How do I undo this fraction? How do I undo 1/3? Well, I can multiply by 3 over 1. The opposite of 1/3 is 3 over 1. Kind of flip upside down. See that? So if I multiply by 3 over 1 on this side, I better multiply by 3 over 1 on this side. Those will cancel out, and I'll be left with x equals 5 times 3 is 15. And you can check these. You can double check these answers as you go through these. Next, I have 2x minus 3 equals 7. There's a couple things being done to x. I'm multiplying by 2, and I'm subtracting 3. So going in reverse order of operations, I'm going to take care of the subtraction first. So I undo subtraction with addition. I'm going to add 3 on both sides, which gives me 2x equals 10. Now I'm going to take care of this multiplication. The opposite of multiplying is dividing. So I'm going to divide by 2 on both sides, which leaves me with x equals 5. So here again are some basic examples of solving equations, solving for x. Okay, here's a couple more. So in this one, it's a little bit more involved. I have 4, and then in parentheses, x minus 2 equals 3x plus 6. So if you remember the steps I mentioned earlier, I have x's. First thing I want to do is I want to simplify both sides if I can. Simplify both sides. Well, over here on the left, I have like 4 and then in parentheses x minus 2. I want to simplify that down. I don't want there to be any parentheses anymore right there. Okay, well, when I have 4 on the outside here and then in parentheses x minus 2, I have to take 4 times x and 4 times minus 2, or negative 2, which gives me 4x minus 4 times negative 2 is 8 equals 3x plus 6. So I've simplified both sides. Now, the next step is I need to get all x's on the same side. Because right now I have x's on both sides. Right? So let's get all the x's on one side. So if I want to get rid of these 3 x's right here, I can subtract 3x on the right-hand side, and I have to do the same thing on the left-hand side. So 3x minus 3x is 0. 4x minus 3x is 1x, you could either write 1x or just x, minus 8 equals, then I'm left with 6 over here. All the x's are on the same side. Now, I just need to get x by itself, following my order of operations in reverse. Order of operations in reverse. So I need to, here, in this case, I need to add 8 on both sides, which gives me x equals 14. If I double check that, let's plug that back into my equation, make sure it works. 4 times, let's see, 14 minus 2 is 12. So I have 4 times 12 over here, equals 3 times 14, plugged 14 in for x, plus 6. 4 times 12, well, that's 48. 3 times 14, that's 42, plus 6 is 48. So indeed that works. Both sides of the equal sign are equal, which is what I want. Okay, over here I have 10x plus 2 divided by 4 equals 8. So, what do I need to do here? I have like this big fraction. I don't really love this big fraction having stuff on top and on the bottom of the fraction. So what I'm going to go ahead and do is, in order to simplify both sides, I have this big fraction, which is basically a division sign, right? I have 10x plus 2 divided by 4. Well, if I don't want this 4 here anymore, the opposite of dividing is multiplying. So if I multiply 4 on this side, those 4's will cancel out, and I'll multiply 4 on this side. So that will leave me with 10x plus 2 equals 8 times 4, which is 32. Then again, I'll follow my order of operations in reverse. I'm going to subtract 2 on both sides, leaving me with 10x equals 30. Then I'm going to divide by 10 on both sides, leaving me with x equals, let me draw a little arrow, 30 divided by 10 is 3. And if I plug 3 back in here, let's double check that it works. 10 times 3 plus 2, well that's 10 times 3 is 30, plus 2 is 32, divided by 4 is indeed 8. So it works. I double check my work. We're all good. Okay, we're going to skip these ones. I'm going to do a couple off of your homework assignment. We'll come to those a little bit later. But again, that was just a general review. Hopefully you already knew how to do some of those. Hopefully those were vaguely familiar. Hopefully now you feel a little bit more comfortable solving equations for a given variable using multiple steps. You can rank yourself there in your guided notes. Before we finish this video, I am going to pull up the homework assignment, and I'm going to do a couple of the homework problems, so you can kind of see a couple of the more unique homework problems and how to go about